Hello students. Module 4 and Module 5 are named as Differentiation 1 and 2 respectively. Obviously this is something important enough to take 2 modules. Actually, it's more than that. What do you mean by differentiation? To differentiate is to find out the derivative function. And that's something we had been doing from Module 3 as well, so this is not a topic for 2 modules, but 3 modules actually. Speaking of Module 3, let's review a little bit. This is the definition of the derivative function. The function given by the derivative values, or the instantaneous rate of changes. And then here are some rules to find out the derivative functions, which we call differentiation rules. These are elementary rules or trivial rules. Derivative of constant is 0. Derivative of sum is sum of the derivative, and then the coefficient you can multiply at any time, either before or after. Here are other elementary differentiation rules, non-trivial rules I should say. These are trivial, these are non-trivial. Power function, you multiply by power and subtract from the power. Natural exponential function remains the same. Natural log function becomes 1 over x. What if you have arbitrary base a instead of natural base e? Well, the recurring theme is log of a. You either multiply by log of a or you divide by that. After all, exponential and log are inverse of each other, so we have multiplication versus division. We're going to prove all these rules later, but now is not the time. We went through all these problems earlier, so let's just move on. And the same goes to tangent line. Y-coordinate, derivative function, slope, and finally the slope point equation. So much for the review. That was quick. Now let's move on to the next topic. Product and quotient rules. Here we go. It turns out that the derivative of product is not product of the derivatives. Same goes here. The derivative of quotient is not the same as the quotient of the derivatives. You see? Remember this. These are incorrect. We have something far more complicated there. But if you look at this closely, then you'll see some similarities here. You have u prime v and then uv prime, and that's being repeated in the numerator here, u prime v minus uv prime. And then the denominator v squared is so conspicuous that hardly anybody misses it. So the key is plus versus minus, and otherwise the same. So there goes the product rule and quotient rules. We'll prove these, but now is not the time. Let's go over to example problems first, complete everything, and then we're going to come back and prove these. Here's an elementary problem. This is a good exercise, so let's go ahead and do that. Excuse me, I think I clicked the wrong key. Okay, and let us rewrite this thing in power form, because it's always more useful to have the power form. Okay, let's find out the derivative of this thing using the product rule. Basically, it's a derivative of the first function times the second function plus first function times the derivative of the second function. That's the structure of the product rule. And then you can fill out this blank and that blank. This is what I usually advise my students. Instead of trying to do this all at once, the structure first, and then fill out these brackets later. That's a good way to cut down mistakes, and in order to emphasize that, I'm going to use two separate lines here. Oops, I think I missed this. Okay, alright. And then I'm going to come back and fill out these dots. So what's the derivative of the first function? Derivative of w is 1. The derivative of exponential, as usual, it remains the same. How about the second function? The derivative of 3 is 0, and then the derivative of the power function, power comes out, and the subtracting 1 from the power. And there goes the problem. Most students will feel like going directly to the second line here, but personally I'd like to discourage that at least for 1 week. Get the structure first, keep these blanks empty or dots or something like that, and then fill those out in the next step. Basically, I'm trying to slow down, and by slowing down, I'm trying to cut down mistakes. Well, it's already here, so we don't need duplicate answer keys. On second thought, let's keep it. I like the second answer key a little bit better because the previous one I sped up a bit too much. Let's do the same thing here. It's product of two functions. It's just that I have to deal with some power functions. 4 over x to the third power. What is it? This is 4x to the which power? How about square root of x? It's half power function. This one, 1/4 is the number part. X to the which power? Negative 1/2 power. And then let's find out that, oops, somehow I clicked the wrong key. And let's find out the derivative, again using the product rule. How does it go? The derivative of the first function times the second function, u prime v, plus the first function times the derivative of the second function. And I'm going to fill in these blanks a bit later. So in the first step, I got the structure of the product rule and filling in these blanks that can wait. Okay, let's fill these in. We want the derivatives here, so this is going to be 2x plus 3 minus plus 12x to the subtract form from the power. Did I do this right? Okay, u prime v, u, now v prime, let's work this one out. 4 times 1/2, 2x to the subtract form from the power, negative 1/2 power, minus 1/4, but I multiply by negative 1/2, so this is going to be plus 1/8, x to the subtract 1/2, subtracting 1 from negative 1/2, so negative 3/2. There goes my derivative function. Yes, it's the same thing, but I prefer this answer better because, well, basically I'm slowing down and I'm asking you to slow down, and this is how you do it. Power form first, and then the structure without the derivative computation, and then we are doing the derivative computations. If you try to do all at once, then you are basically inviting yourself for possible mistakes. Let's do one more, and then in the next video we'll do quotient rule problems. How about this one? The derivative of first function times the second function, then first function times the derivative of the second function. Okay, what's the derivative of the first function? E to the x power. And what's the derivative of the second function? And you can answer like this. Now it looks like I just spent one line, not like the way I did before, but as a matter of fact, I follow the same scheme. It's just that I got the structure and then fill those in later. And that's what I just did. Well, do we have time for quotient? I think we do, so let's go ahead. Let's go ahead with quotient. Okay, what's the quotient rule? Here's the structure of the quotient rule. U prime v minus uv prime over v squared. Here in this case, denominator squared is really conspicuous. Let me increase the font a little bit. Okay. And then let's take u prime v. So derivative of numerator times the denominator minus numerator times v prime, derivative of denominator. This is the structure of the quotient rule. And then let's just fill in the derivatives here. 3t squared, excuse me, plus 1. Here, derivative of denominator, this is for v prime. 4t cubed minus 0. I don't need minus 0, but I wrote it anyway. We have one more problem. Okay, let's go. So it's like this. U prime v minus u v prime over v squared. That's a quotient rule. And then the denominator is really conspicuous, so it's easier for me. X plus log of x squared. And then let's put the structure of the quotient rule to the numerator here. U prime v minus u v prime. Okay, u prime we're going to consider it later. Just copying down first x, and then copying down x squared plus exponential x. So what is this? U prime v minus u v prime over v squared. We got the structure of the quotient rule. And in these brackets, we can put in the derivatives. 2x plus e to the x power. That's the derivative of the numerator. How about here? Derivative of the denominator. 1 plus 1 over x. That's v prime.